Back in the day when the world was black and white, if you wanted to book a holiday or a hotel, you had to go to travel agents and have a look through a catalogue. These days, websites exist to allow us to book bespoke hotels from our home computer. And in this example, we're going to book a holiday for Christmas in Larne. We see that on putting the search term, a drop-down menu was displayed, giving us a number of search options. This can be programmed in the database itself using SQL, which is known as structured query language. And many of the advanced features of this website are due to front-end design and are essentially a USP of the site. In other words, they create the user journey. Ultimately, a satisfactory user experience, though, depends on the behind-the-scenes functions of the database. And we have used PHP MyAdmin and the structured query language to recreate a searchable database for a hotel booking system. The entities and the attributes, of which there are many. For example, we're looking at amenities here. We've got 24-hour front desk, multilingual staff, free Wi-Fi, the various attractions that are around the place, and information, photographs of the hotel. They've been normalized out to create a relational database, and a ERD, entity relation database, is shown here. In this case, for example, we've normalized out the data relating to the address, county, and the country. And one could argue that the address tables might contain all these attributes in reality, and why is it necessary to normalize data to a separate table? In a small database, it wouldn't really matter much, but in databases the likes of Booking.com, they're estimated to have in excess of 29 million entries. Then the normalization of this data, such as postcodes, allows for more accuracy and less room for error. So, for example, if we input, using our SQL, if we input the select all from the hotel table and click go, then we should find all the information of all the hotels and the small sample size that we have available for this project. More advanced search options are available, and we'll bring up data relating to the search for country, for example, or indeed multiple countries. Here we have a select all from the table hotel again, where the country ID is 1 or 2. I believe that is China or France. Find yes, indeed. We bring up 4 hotels, 2 from China, 2 from France, and they give us the information: hotel description, accommodation type, star rating, and then the address ID also. Searching for a hotel by name can prove difficult. For example, here we've searched select all from hotel, where the hotel name is like Grand. We've got these wildcards either side of the word Grand, and if we press go, we will find that there are 3 within our small sample size. We have 2 on the south coast of England, and also a 3rd one in the Far East. We have queries which can insert data into our tables. We have inserting into the room table here, for example. We've got the room ID, which is auto-incremented, room name, features, how many rooms are available, and then also the hotel ID. And we're going to put null into the first one because that's auto-incremented by PHP MyAdmin. Room name is going to be the Bailey, and we've got 1 of the features and 3 rooms available. Okay, so if we browse that, then we find that we have, yes, indeed, 2 rooms, the same hotel, funny enough, and one of them known as the Bailey, with 2 Morrison themed rooms, I suppose. 3 and 5 of those are available, and then 3 of the Bailey, which we just entered there. We can also update the room. We're going to set this particular room name to Hope. Okay, if we click go, yes, we really do want to update this, and again we browse to see what has happened. Oh, when we see that they've all changed to Hope there. But again, the same number of rooms are available. I guess we could be more specific regarding that. Again, going back to our entity relations diagram, we're going to look at the hotel and hotel features. These two tables are linked by the primary key within the hotel table, which is hotel underscore ID, which then serves as the foreign key in the hotel features table. This has got free Wi-Fi, restaurant, free parking. We're going to look for the free Wi-Fi, or the hotels which offer the free Wi-Fi. So again, select the hotel ID from the hotel features where free Wi-Fi is present. That's a Boolean essentially, where 1 means that it's there. And if we click on there, then okay, then we find that we have 8 of the hotels of the 11 offering free Wi-Fi. If we hover over the number here, the hotel ID, it'll give us the name of the hotel. But we can probably do a little bit better than that if we're slightly more specific with our search query. And we'll do a left join here, where we select all from hotel features, and we're going to join the hotel features table to the hotel table, essentially. And there we go. So we have the hotel features, Wi-Fi, restaurant, parking, also joined to this table now with the hotel name, description, and the accommodation type as well. We can further break that down. For example, if we're looking at free Wi-Fi, the accommodation type, again, whether it's a luxury hotel or a boutique or a bargain hotel, essentially. And running that query gives us an ordered list, actually, here of the because we've ordered it by accommodation type, essentially. Moving on then, okay, so we get to the, we're talking about passwords essentially here, and we've been given the code for this for this particular option, and also the warning that we're not to use this essentially because for passwords, essentially what we're performing is a hash using the secure hash algorithm SHA-1, and then salting that as well so that it changes and we can store the password in a secure way. But it's not industry standard. These days, normally passwords, sensitive information like credit card details, are stored on external sites. And so here we have Jimmy John Joe, and he's been very creative with this password here. I think we'll see in a minute that this has evolved ever so slightly from his initial efforts. This eventually gets going, lovely, and click on Browse. And the SHA-1 algorithm was invented by the NSA in 1995. And we can see that with using the same password here, once we've hashed it and then salted it, we're now getting different pseudo encryption, essentially, because we don't need to go back to the original password. And we do not want to store this password in a database because it's essentially insecure. And with SHA-1 now being cracked, it's not secure at all. I think we're on to SHA-3 the last time I checked, and that involves a different pattern altogether. The information on the characters that are stored as var binary rather than varchar or int, purely because the SHA-1 converts the password into a binary, and then the salt is concatenated onto the front of that. And then finally, we'll have a look at credit card encryption. Again, this doesn't meet PCI industry standards. So if we update all this information, quickly browse it, we'll find that Brian has got his password, his credit card details encrypted. Mrs. Chanel here has been going a bit mad. You can see that she's got 3 credit cards of the same number, which again have the same AES encryption. A different number gives a different encryption result. And that is the end of the presentation, and thank you very much.